My dear students, in the beginning of the chapter 9, applications of integration, for the past two videos, I have listed the results in integration, the important results I have discussed in the previous two videos. On the basis of those results, we are going to solve the problems in the exercise. And in this video, I am going to introduce definite integrals. Definite integrals. See, when I am introducing the topic integrals, integration is the reverse process of differentiation. I told you, that derivative of cos x or derivative of sin x you can take simply. Derivative of sin x is cos x. If you take cos x, it is minus sin x, nothing difference. If you consider derivative of cos x, it is minus sin x. So I want the positive sign, therefore I am taking the derivative of sin x is cos x to know. And that integral of cos x into dx is equal to sin x. This is the reverse process. Differentiation of sin x is cos x. Integration of cos x is sin x plus c. C is an integrating constant, as I told. So integration of cos x is sin x. So integration is the reverse process of differentiation. And this sin x is called the antiderivative of cos x. This function sin x is called antiderivative. Antiderivative of sin x is the antiderivative of cos x. See, this is the general idea of integration. For the case of different integrals, if you find out f of x, definition, if f of x is a continuous function, f of x is a continuous function in a closed interval, f of x is a continuous function in a closed interval a comma b. F of x is a continuous function in the closed interval a comma b, and capital F of x is, d. Capital F of x is an antiderivative. If capital F of x is an antiderivative of small f of x, then f of x is equal to integral a to b small f of x dx. The answer for this is, after integration we will get f of x, therefore first you apply the upper limit f of b, then lower limit f of b. The answer for this integration is f of b minus f of b. This is the definition for definite integral. It's also, we call it as a theorem, fundamental theorem. It is we can say it's a fundamental theorem on definite integral. If f of x is a continuous function in a closed interval a comma b, and capital F of x is an antiderivative of f of x, then integral a to b f of x dx is capital F of x, whose value is capital F of b minus capital F of b. So using this idea, we are going to solve the problems in the exercise which is given in the topic applications of integration, exercise number 9.3 in the state board syllabus, 12th standard. Okay. We will see the problems one by one in the exercise problems. This is the value of this is the value of evaluating a definite integral. Integral a to b f of x dx is capital F of b minus capital F of b. Lower limit, upper limit minus lower limit. Now we will come to the exercise number 9.3. Exercise 9.3. Evaluate the integral. Evaluate integral 3 to 4, lower limit 3, upper limit 4, dx by x square minus 4. So this is integral 3 to 4 dx by f of x is x square minus 4 is, you can write it as 2 square. This 4 can be expressed 2 square. This is equal to, you know, an integral value, integral or one result we have given in our previous video, integral dx by x square minus a square, integral dx by x square minus a square equal to one by 2a into log of x minus a by x plus a plus c. If it is indifferent integral, you will get an integral equal to c. In the case of different integrals, the concept will not occur, but the result is this: integral dx by x square minus a square equal to 1 by 2a into log of x minus a by x plus a. You apply the result here. Integral 3 to 4 dx by x square minus a square, a is 2 square. Therefore, you are by the result 1 by 2a, a is 2, log of x minus 2 by x plus 2. Now you apply the limit 3 to 4. After integrating, you will apply the limit. You will get 1 by 4 into, first you get upper, you use the upper limit, log of if you put x equal to 4 for upper limit, applying upper limit 4 minus 2 by 4 plus 2 minus, and then lower limit 3 f of b minus f of a, by definition log of lower limit 3 minus 2 by 3 plus 2. See, applying the result, you will get a square is 2 square, so 1 by 2a log of x minus a by x plus a, x minus 2 by x plus 2, applying upper limit first, 1 by 2 into 2, 4, log of 4 minus 2 by 4 plus 2 minus lower limit log of 3 minus 2 by 3 plus 2. So that is equal to 1 by 4 into log 4 minus 2 is 2 by 6. 2 by 6. Okay. Minus log of 1 by 5. This 2 by 6 you can simplify as 1 by 3. It is 1 by 3. Therefore, this is equal to 1 by 4 into log of 1 by 3 minus log of 1 by 5. By definition of logarithm, log m minus log n is log m by n, you know. Log m minus log n is log m by n, therefore you will get 1 by 4 into log of 1 by 3 by 1 by 5. This is log m by log n. That is 1 by 3 into 5 by 3, that is 5 by n is 5 by 3. This is equal to 1 by 4 into log of 5 by 3. That is the answer for this problem. 1 by 4 log of 5 by 3. That's all about the problem. Using this result, which I have given in our previous video. Previously I posted 2 videos in integration. So far we have posted 2 videos, and those videos I have listed all the results of integrations. Using that result, we are going to solve the problems. That's all about the problem. Next, second one. Evaluate just to remember the results, then only the problems will be easier to solve. Next, the second one. Evaluate integral -1 to +1 dx by x square plus 2x plus 5. To solve this problem, you consider this as integral -1 to +1 dx by x square plus 2x plus 5. I can split that denominator expression as x square plus 2x. I can split this as x square plus 2x plus, I split this 5 as 1 plus 4. I write this 5 as 1 plus 4. Why I am writing this is x square plus 2x plus 1, x square plus 2x plus 1 as one term, and the remaining 4 is another term. You club this into 2 terms up to this. This is equal to integral -1 to +1 up to this dx by x square plus 2x plus 1 is x plus 1 whole square plus 4. 4 I can write as 2 square. This is x square plus 2x plus 1 is x plus 1 whole square plus 4. This 4 I can write as 2 square. This 4 can be expressed as 2 square. So it is of the form integral dx by x square plus a square. It is again a result integral dx by x square plus a square. Integral 1 by x square plus a square is tan inverse x by a. Integral dx by x square plus a square is 1 by a into tan inverse x square by a square. Integral x square by a square is 1 minute. Yes, 1 by a into tan inverse of x by a plus c. Tan inverse of x by a plus c. For that, here this is equal to 1 by a is 2 dx by x square plus a square. X is x plus 1 whole square. Instead of x we get x plus 1 whole square. A square is 2 square. So by using that result 1 by a is 2. Tan inverse of x is x plus 1 by a is 2. So 1 by a into tan inverse x is x plus 1 by 2. That's all, from -1 to +1. So first apply the upper limit. 1 by 2 into tan inverse of, you are applying upper limit 1 plus 1 by 2 minus lower limit tan inverse of -1 plus 1 by 2. That is equal to 1 by 2 into tan inverse of 1 plus 1, 2 by 2, that is tan inverse 1. That is, this is tan inverse 1 minus tan inverse 0. Because 1 minus 1 plus 1 is 0, 0 by 2 is 0. That is equal to 1 by 2 into tan inverse 1 is 5 by 4. Tan 45 1, tan inverse 1 is 5 by 4. Tan inverse is 0. So 5 by 2 into 5, 1 by 2 into 5 by 4 is 5 by 8. So answer for this problem is 5 by 8. That's all about the problem. Second one. Next we will see the next problem in the exercise. Okay. Like that, you can solve the problems by using the ideas of results we have derived, we have discussed in the previous videos. And also those results you have studied already in your 11th standard. So each problem is solved by using a result which you have studied already. Okay. Next one, third problem. Integral 0 to 1 root of 1 minus x by 1 plus x dx. Root of 1 minus x by 1 plus x dx. See, to evaluate this integration, integral 0 to 1, within the square root you multiply by 1 minus x both by numerator and denominator. You multiplied with 1 minus x both the numerator and denominator. 1 minus x by 1 minus. Multiplying numerator by 1 minus x and the denominator by 1 minus x. You will get, to compensate this, to evaluate this problem, you have to multiply both by numerator and denominator. Numerator will get 1 minus x whole square. Denominator 1 plus x by 1 minus x is 1 minus x square. 1 square minus x square. Numerator is 1 minus x into 1 minus x is 1 minus x whole square. Denominator a plus b into a minus b form. 1 plus x into 1 minus x in algebra, you will get 1 square minus x square. So this is again equal to root of 1 minus x whole square. Numerator you will get just 1 minus x square only. Root vanish on taking square. Sorry, 1 minus x. Square and square root vanish, you will get just 1 minus x by, you will get denominator, you will get one root of 1 minus x. In the denominator, you will get root of 1 minus x. Okay, numerator root is vanished by the square. Now you split this integral into two integrals. Dx. Integration simple, as dx always. Now I am going to split this into two integrals, that is equal to integral 0 to 1, 1 by root of 1 minus x square dx plus integral minus x by root of 1 minus x square dx. It is also limit 0 to 1. So I split this integral into two integrals. 1 by root of 1 minus x square dx minus plus minus x by root of 1 minus x square dx. For this, the first integral is nothing but the direct formula 1 by root of 1 minus x square is sin inverse x. This is sin inverse x from 0 to 1 over plus, to evaluate this integral, you will substitute 1 minus x square as t. You substitute t equal to 1 minus x square. Therefore, dt is x square derivative minus 2x into dx. Derivative of 1 is 0, x square is 2x into dx. So you bring this 2 here, dt by 2 equal to minus x dx. So in the numerator you will get minus x dx, you can replace by dt by 2. And the root of 1 minus x square by root t. And also the limits are also changed. These are the 0 and 1 are limits of 0. Corresponding the limits of x is replaced to limits of t. If x equal to 0, what is t? T equal to 1 minus 0, that is equal to 1. t equal to 1 minus 0 square, that is equal to 1. Similarly, if x equal to 1, t equal to x equal to 1 minus 1 square. 1 minus 1 square is 0. So the limit 0 to 1 is replaced by 1 to 0 to 1 to 0. 0 to 1 is 1 to 0. The limit changes as 0 to 1 becomes 1 to 0 minus x dx. Minus x dx is dt by 2. X square is s t s 2x minus 2x and dx minus dt by 2. Okay. dt by 2 into root t, because 1 minus x square is root t. We are replacing 1 minus x square by t, therefore this is root t. So this is sine inverse upper limit, sine inverse 1 minus sine inverse 0 upper limit over plus 1 by 2 into integral 1 to 0 dt by 1 by root t, t power of minus of. This is t power minus of plus 1, therefore t power of by of on before that 1 by 2, I would say root t is expressed as t power minus of dt. It can be expressed as t power minus of plus 1 by minus of plus 1, but is t power of by of. What do you get? This is sine inverse 1, sine 90, therefore this is pi by 2. Sine inverse 0 is 0 plus okay, 1 by 2 into on integration it becomes t power minus of plus 1 is t power of by 1 to 0. See, this is equal to pi by 2, 0, leave it 1 by 2, 1 by 2 cancel. You will get t power of 1 to 0, that is equal to pi by 2 minus first t power 0. Instead of t substitute 0, 0 power of is 0 minus 1 power of is 1. Okay, this is plus sign. Pi by 2 plus 1 by 2. 1 by 2, 1 by 2 cancel. This is plus here. So this is plus into minus, minus 1. Therefore your answer is pi by 2 minus 1. See, that's all about the problem. Here, this is direct integration, 1 by root of 1 minus x square is sine inverse x 0 to 1. Here you substitute 1 minus x square equal to t, minus 2x dx is dt, dt by 2 equal to minus x dx is dt by 2 and root t, and 1 by 2 you can take outside, t power off by off cancel, only root t, t power 0 0, t power 1 is 1, therefore answer is 5 by 2 minus 1. Okay? You see, this is direct integration. Here you have to say integrate by the substitution. The substitution is here. I am giving the substitution for 1 minus x square equal to t. Correspondingly, the limits of x should be changed into limits of t. If x equal to 0, t equal to 1 minus 0, 1. If x equal to 1, t equal to 1 minus 1 square is 1 minus 1, 0. Therefore, 1 to 0, 0 to 1 becomes 1 to 0. That's all about the problem. I will stop the video here. We will continue the remaining problems in the next video. Thank you.